the XE exploit type thing. And that was accidentally rolled out by a homebrew, like not because it wasn't activated on Mac, so it was like the code was technically safe on Mac, but it was a version that the attacker had access to, and had released. And Homebrew had, like, by default, rolling releases. So if you had run Homebrew update or Homebrew install anytime within the release window, then you would have had it running on your system. Whereas a bunch of servers didn't have it running because they're like 3 versions behind.
Sure.
Which has its own problems too. But and that was actually a good example of the trade-offs between like security and performance, because a lot of the improvements that were being made were related to performance. So XC is like this compression library that is used in a bunch of random places. Like it's used in Python, and it's used in all kinds of different things. So having a performance increase for that might mean that your software generally works better for free.
Yeah.
But then if you're having rolling releases where you're deploying whatever the latest version published by the authors is, then you have to trust the people who deployed it, packaged it, added code.
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Noah Hall, a programming language creator and a technical leader at Norway's largest news company. We start off talking about a security issue he faced with WordPress on a personal project he did to help out a local charity, and then get into a detailed discussion of how different software projects balance needs like security, performance, dependency updates, and more, including the effects that generative AI is having on all of these considerations. I want to give a massive thank you to everyone who's been supporting Software Unscripted on Patreon. If you'd like to become a supporter too, check out patreon.com/softwareunscripted. And now, securing evolving software. So, you mentioned at some point that you had been working on a charity and they were using WordPress, and you transitioned them away from WordPress and towards just plain old school static HTML, CSS. I'm really curious, like, what was the motivation there and how did it go?
Yeah, so this charity happened to be run by someone who lived in my building, and I reached out to them about a totally unrelated thing. I wanted them to speak at an event I was hosting. And when we met up, we realized we lived in the same building, and that they had this problem with their website, which was written in WordPress a long time ago. And as WordPress tends to have, it had a bunch of security problems, and therefore was taken down by the ISP. And I was just like listening to what they were actually using it for and how often they updated it. Turns out they weren't updating it that much. And then I got sort of the inkling of like that feeling where you think about a problem and you think, oh, I bet I can do that in like 4 hours. Like I can recreate that in 4 hours. So that's what I ended up doing, is just looking at it and figuring out which parts could just be static HTML, which parts could be CSS. I also set like a little goal to myself of not using any JavaScript. And there was like a menu that was previously in JavaScript, like, you know, the fancy kind of navigation things. I ended up just doing that in straight CSS and worked out okay. And I think it's kind of a recurring thing that I've seen people do, where they go for a solution that is well known. So that's WordPress. That's flexible. That's also WordPress. But it also provides way too much functionality for what they need.
That's also WordPress.
It's also WordPress. It's also WordPress. And it's not just WordPress itself, but also plugins. Like there's so many plugins for WordPress. And if you are producing a bunch of content and you need a CMS to manage it and that kind of stuff, then I think WordPress is a totally valid option. But if you mostly have a static site that you're not really updating, you maybe update it once a year or maybe twice a year, then a lot of that functionality is kind of lost on you, and you got to pay the cost of, like, not the cost in money, but the cost in complexity, because instead of just having HTML files that you can modify, you have to have a database that stores all the WordPress stuff. You have to have a hosting provider that runs PHP. You have to have the plugins that you want and keep them updated. Fortunately, these days you don't have to do much to update HTML. Like,
Right. Yeah, I
Yeah.
was reading that I was reading one of the original announcements of HTML, like Tim Berners-Lee, back in like 1990. And one of the things that struck me was that it explicitly mentioned in the document, okay, if you're a human editing this HTML, then here's what you might want to do. And if it's a HTML authoring tool, then do this. So it seems like from the very beginning, there was this idea of HTML having this dual purpose of being edited by humans, but also being edited by some sort of like WYSIWYG editor or something like that was just generating it. And I think it's interesting that in practice these days, like I remember like Dreamweaver back in the day was like a big popular like WYSIWYG editor. But these days it seems like overwhelmingly there is a dual use case, but it's not that. It's not WYSIWYG. It's more like you have edited by hand, and then you have the much more common these days, like you write code that generates it automatically.
Yeah, and it's interesting if you look at those like really early internet or HTML screenshots and stuff, where it's really so basic. Like it's just text that's formatted in a bit nicer than usual, which is not how most websites are made today.
True.
But you can make a lot of that functionality just with different tags and element types and a bit of CSS. Gets you a long way further than like a lot of people think. The default reaction sometimes is, okay, we're going to make a site. It's going to be complex at some point. Therefore, the infrastructure to support it has to be complex too.
Classic.
Because that will make it easier. Like it will simplify the hard parts. But in this particular case, like, you really don't need a full WordPress site to get some kind of really nice landing page and that kind of thing.
Yeah, I have a personal blog, and I kind of went in the direction that you went from the get-go because, of course, there's this classic meme of like, I'm going to start writing a blog. The first thing I need to do is spend 6 months building a custom blog engine for myself. But I didn't do that in part because I was already planning to not write to it that often, mainly just to post updates about Rock. And I think I've done like 2 or 3 of them now. I don't even have a homepage right now. You have to like link directly to you have to know exactly the URL of the post. I'll get around to that eventually. But that was one of the things that I decided was I was like, yeah, I think I may have used like a little Rock script to generate like some common, I don't know, like baseline page stuff, like the borders and the mobile versus whatever. But the actual body, that's right. I think I started off in Markdown, and then I run a little Rock script to turn the Markdown into HTML, just because for the first draft it's easier. But then I did actually tweak and check in the actual generated HTML because I'm like, look, if I'm regenerating this all the time, that's going to be really annoying, but I don't plan to. And actually, some of the stuff I want, I can make it just a little bit custom. Like in one of the posts, I used some MathML for like to show fractions because it was a post about numbers. And it's like, yeah, I don't want to figure out how to like make that work in with a Markdown. I'm just going to add the HTML. It's fine. And those type of things I think are underrated. It's really easy for us to get in our heads about like, oh, I'm always going to be regenerating this all the time, and I'm going to need all this stuff in the future. It's like, yeah, I haven't touched them as planned. Like I haven't gone back and edited them even once, so I don't regret any of that. And in fact, I think if I'd gone the other way, I would have regretted over investing in making it really generic and automated.
Yeah, and actually, the blog, the distinction between making a blog engine versus writing a blog post is something that I think about a lot because I like making games, and when I'm making a game, my first instinct is right. Okay, I need to make a game framework.
Right.
And
Yeah.
then I spend all the time like making the framework, never making the game. And then suddenly I've realized like, what was that like really good idea I had? I didn't actually do it.
Right.
um, and it's the same with like frameworks in general. Like sometimes it's better to just make the thing that you want to make. So if you're making a blog engine because that's what you really are passionate about, then that's the good way to spend time. But if what you're trying to do actually is write a blog post, it's better to find the mechanisms that allow you to do that part as easy as possible. Um,
Yeah.
my personal, that's how I see it these days.
I think that's a healthy way of seeing it, but also I think there's even more nuance than that, which is I think there's a whole like middle ground there where I think often we think about it as this binary. Like it's like either you make a generic reusable framework that everyone on the planet can use for every use case, or you make this completely bespoke hard coded thing that's only for you and is like not customized or not generic in any way. And I think that there's a lot more value to be found in a lot of those in between states. For example, I was talking with somebody earlier who does game dev with or used to do game dev with like big like AAA game engines, and he said like basically every shop forks them and customizes them themselves. And it's like,
Yeah.
yeah, you can do that. Like in the web dev world, that's really unheard of. Like very few companies are like forking Rails and customizing it, or forking React and customizing it. But you could. And I think part of the reason we don't is because there's this like update treadmill of like, oh no, the new version is going to come out any second now. So like I'm not going to want to keep up with that. But it's like, well, do you have to? Like, I don't know, maybe like, I don't know. Personally, my favorite version of React was like 0.8 ish. Like I think it's kind of been downhill from there. So, but I mean, I wouldn't use React again anyway. So, maybe I'm not the right person, but having said that, I mean, there's also the other end where it's like, I know that there are some game developers, like I had Mason Romali on earlier, many episodes ago, and he was talking about the game that he's making, where it's not so much that he's making a game engine, but rather that he made all the game engine sort of stuff himself for his game, even though it's kind of just one title. And I know like Jonathan Blow is famous for this in like game development. Like he just like every game they make a quote unquote, it does something that does all the things the engine would do, but it's just for that one game. And I think back in the day that used to be more common than not. And like nowadays it's the opposite. But I guess the further back you go, I think it was like some early games. I think there was like the Scum engine with 2 M's, which was for like adventure games. It was like one of the earliest famous like actual reused things. And before that, everybody would like just build their own bespoke one every time. And there's some elements of like, well, maybe it's wasteful to do that rather than getting something off the shelf. But there's another aspect of like, yeah, but some customizations are really valuable and like actually make the end product, the one-off, the actual thing that people are going to consume, whether that's the blog post or the game, better because they're built in a way that wasn't that generic and was like able to be customized and specialized for that use case.
Yeah, I think it's you see it sometimes with like language runtimes. So like I think Iron Python, it was written for Python 2.7. And I'm not sure if it's on 3 now. It might be. But I know there's like a big delay between the features that you would get on like mainstream C Python versus like Iron Python. But Iron Python, and maybe Iron Python is a bad example, but that gives you a way to interface with .NET code from Python code, which sounds pretty cool because it runs on .NET, I believe. But then at the same time, because you've kind of like forked it and customized it a bit in order to do something different, it's a lot harder to bring in any big changes.
Right.
I think it's like a balancing act for sure. Like,
right. And yeah, like if you plan on getting updates from upstream a lot and you plan on those being valuable, I guess the more valuable you anticipate that being, the more it matters that you're the more there's a cost to forking and customizing, which totally makes sense. But I do think it's reasonable to question how valuable those updates are in a lot of cases. Like these days, I'm old enough to have remembered many different phases of React, some of which I was like actually developing React, like using React as a developer, and some of which I was just kind of a passive observer. But I remember hearing about hooks coming out and looking at it and being like, I don't get it. This doesn't seem like it's like solving a real problem. I did have an episode where I was talking with someone who was sort of defending the design of hooks, and sort of explaining like the motivation for like what problem they were solving and so forth. But still, I do get the sense that like the overall vibe for a lot of people is sort of like, well, this is how things are now, and it's like kind of complicated and confusing, but it's, I don't know, it's how things are. But like you didn't have to upgrade. Like you could still just continue to use an older version of React. I get it. That said, if there are security concerns, that's a little bit different. Like you mentioned, WordPress having security problems, that being a primary motivation for wanting to move away from it. But like in the case of React, it's like, what security concerns do you really have? I don't know.
Yeah, I guess security, I reckon, is a big one, particularly for sort of web server type stuff. There's also like performance related things. So like the React compiler, or whatever they decided to call it now, where it inlines a whole bunch of logic, so you don't have to do as many expensive renders or paints or whatever. I think that's a good motivator to upgrade, but I also think as developers, there's two kind of common things we fall into. One is that we have things that we never update, and they just keep running on like some dangerously old version that nobody knows how it works anymore.
Yep.
And there's the other side of like adopting things as soon as they come out.
Yep.
And I think nuance is so important for these kind of things, where if you have a system that runs and nobody knows how it works, there might be a reason why you have left it like that. Like it might be expensive to replace it, like COBOL, for example. Like these systems that are still using COBOL, if there was a better option for that didn't involve a bunch of like developer time and like increase the memory or CPU time or whatever, then people would have shifted to a better thing probably by now, because there's so few COBOL experts and that kind of stuff.
Yeah, that's a good point. I mean, there's some cases where upgrading is desired, like you thought about it and you're like, yes, we do actually want to upgrade, but it's hard because the thing that you chose in the first place turns out to be difficult to upgrade, or in COBOL's case, I guess, to migrate away from. Yeah, that's a separately tricky problem, I guess, is like what happens when you want a big fundamental change and not just an upgrade? Like, what's that experience like? And I guess there is an overlap with upgrades in that some upgrades are backwards compatible technically, but in practice, if you want to actually use the new stuff, like you're not going to benefit from any of the upgrades unless you do a big expensive change. And so it's like, well, by upgrading, you're going to get certain things for free, quote unquote, because it was backwards compatible. But backwards compatibility is not the same thing as ease of upgrading if you want to actually get the new benefits.
Yeah, I think it's interesting what Swift has done with the Xcode like upgrade version of your code thing. I can't remember what they call it, but it's similar to the 2 to 3 or 3 to 2 utility that Python had during the 2 to 3 migration, where it will like go and look at your code and upgrade it to whatever you need it to be. And we had something similar for Elm at some point, where Elm upgrade would like change how imports were and like
this, and
stuff. And that means it's very easy to upgrade because you don't have to spend any developer time other than like running the script and then deploying it to staging, I hope, and then verifying it works and that kind of thing. But I think it's kind of like it's kind of painful if you have to manually constantly upgrade things and then figure out why they broke yourself. Like
totally. Yeah, and I guess it depends a lot on how reliable that tool is. Like if the tool consistently does a good job and is just like, yeah, this works the same way as before, but now it's in the new system, great. If that's true 95% of the time, that's not nearly as good, but it's still pretty great. if it's true like 70% of the time, now it's like, oh, I don't know. like, I got a lot of individual cases to track down anyway. Like,
Yeah, there was this like I remember there was a node upgrade from like I can't remember the exact version it was. It might have been 16 to 18, and in that upgrade was a huge performance boost. And I remember seeing some of the applications running like 4 times better.
wow.
And there were no need for any manual interventions. It just worked. And that's kind of like the dream upgrade where things get more secure, they work the same as before, and they're more performant.
Right.
But then there's also stuff like there was a bug in the latest release of Node that didn't handle SSL as it did before, and that's like a breaking change as a bug, not intentional.
Yeah.
And I know some people who were running like latest Node on every deploy, and suddenly they were like, "Hey, why does this not work like it used to?"
Oh yeah. Yeah, that I've now had that experience in two different contexts. One is that we don't have a numbered version release yet of Rock, and so everybody's working off of nightly releases. As it happened, somebody checked in a PR that had a regression on like the debug feature that like does like debug logging, which is really important for inline debugging. And on the one hand, somebody noticed like, hey, I don't think debug's working at all. And then the person was like, oh, I think I know what that was. Let me push a fix. But on the other hand, it was like, well, because everybody's working off nightly, it was fixed the next day. So, there was a very short window of problems for that. Similarly, at work, I work at Zed, like the code editor, and ever since I joined, I've always been on the like nightly build of the editor instead of the stable build. And there was also a while where there was some regression in like the Vim mode, which is what I use exclusively. And so for a while, I was like, well, I guess I can just go back to the stable build until that gets fixed, which took like 2 days or something in this case. But like, it was fine. And then I switched back to the nightly. It's all good. But there is this interesting trade-off that comes up when it's not just like your Advent of Code project or your personal editor experience, but rather it's like a running production system. Because if you have a bug on that, especially if it's like a security bug and you're dealing with like people's finances and stuff like that, the consequences can be way more serious than just a little inconvenience.
Yeah, it's interesting because it comes up a lot in the Linux community, right? Where you have the Arch, which is rolling release, constantly releasing things, always getting a new stuff.
Right.
And then the more traditional sort of Fedora or Debian style releases where they have a named release and they have different testing phases. So there might be there's a release that is basically nightly, and then there's one that is stable but not quite nightly, but also not full stable. Like full stable, and LTS as well, like long-term support. And I think in my experience, I prefer rolling releases because it means that you're always getting good stuff coming out, and very rarely do you get bitten by something breaking. Some people who use Arch might disagree, but I think it's very rare that something like that happens. But actually, now that I think about it, there's the XC exploit type thing.
I remember that, yeah.
And that was accidentally rolled out by a homebrew, like not because it wasn't activated on Mac, so it was like the code was technically safe on Mac, but it was a version that the attacker had access to and had released. And Homebrew had like by default rolling releases. So if you had run Homebrew update or Homebrew install anytime within the release window, then you would have had it running on your system. Whereas a bunch of servers didn't have it running because they're like 3 versions behind. Sure. Which has its own problems too. But and that was actually a good example of the trade-offs between like security and performance, because a lot of the improvements that were being made were related to performance. So XC is like this compression library that is used in a bunch of random places. Like it's used in Python, and it's used in all kinds of different things. So having a performance increase for that might mean that your software generally works better for free.
Yeah.
But then if you're having rolling releases where you're deploying whatever the latest version published by the authors is, then you have to trust the people who deployed it, packaged it, added code.
Yep. All of that. Yeah. And I mean, there's also an like a broader tension there, which is just anytime you're making change to software, hopefully to improve it, whether that's performance or otherwise, there's always the potential that you're introducing a security vulnerability somewhere. Now, granted, if you limit that to some very specific subset of the code base, the narrower you limit it to, the less likely it is. I mean, if you're just tweaking an integer pixel value, that's very unlikely to cause a security problem. But, you know, a lot of changes, especially performance changes, are doing stuff that's in a place that's more likely, especially if you're talking about like a C or C++ code base, where like, yeah, you might be introducing a buffer overrun or something like that while also making it faster. So there's a little bit of a like, you know, you're upgrading and hopefully you're just getting performance improvements and security improvements, but you might be getting performance improvements and security improvements and also new security vulnerabilities, and they're all packaged up in the same release.
Yeah, there was the CPU, the Intel CPU heartbeat vulnerability.
Oh yeah,
which I think by now, like most systems have it disabled by default, but you actually lose a ton of performance on each of your machines where it's disabled, because I can't remember exactly how it works. Or
this was or was this Heartbleed or was it Spectre and Meltdown? Because I think those are the ones
maybe,
that.
yeah, maybe Spectre actually.
Yeah, it was like
Yeah,
a side channel attack. Yeah, like
yeah,
based on timing, I think. Yeah,
yeah,
speculative execution, I think.
yeah. And some of those things were really interesting. Like I saw this research where you could listen to a CPU and a hard drive and figure out like what's happening
I heard about this. Right, just using a microphone. Yeah,
just using a microphone.
wild. Yeah,
But that was also like, okay, if we leave this running, then our performance remains good and we have good performance. If we disable it, then we lose a bunch of performance. But if we leave it running, you can get exploited, attacked, and therefore, like, you have to eat that performance loss in order to reliably use like half of the devices that we trust our lives to.
Yep. Yeah. Well, there's an interesting question around like at what level do you want to try to defend against these things? Because in one sense, you could say, hey, I'm making a single player game that doesn't connect to the internet, like, and doesn't use any third party mods or anything. Like, does that really need to have Spectre and Meltdown mitigations? Like, probably not. But a lot of other, you know, use cases do need that mitigation in order to be, you know, reliable. And there's a question of like, well, do you let people opt in and out of that, or do you try to apply it blanket across the whole system? Like, at what level do you apply those mitigations? And this actually came up in two contexts in the design of Rock's standard library. One is a decision that we made recently, which is that we are going to put cryptographic algorithms in the standard library for security reasons, basically for the same reason that Go did, which is that if you really want those to be secure against timing attacks, you basically have to implement them using inline assembly. And so you have two options. One is you can either say, yeah, we're going to introduce inline assembly to this functional programming language so that you can implement cryptographic algorithms securely, and now it's a memory unsafe language, which I don't want to do. Or if you can say, like, look, this one use case is kind of an outlier, so we're just going to make built-in, you know, in the standard library, just offer certain cryptographic algorithms that have been implemented using the inline assembly and have been tested and verified and all this stuff, which is basically what Go does. And that seems more reasonable to me given the security trade-offs. The other one was, I don't know, do you know about hash flooding attacks?
Hash flooding. It sounds familiar, but not off the top of my head. I don't.
So the basic idea is like, let's say someone's trying to do a denial of service attack against your web server. A hash flooding attack is where they sort of amplify the attack and make each individual bot that's trying to slam the server be more effective at trying to take the server down by intentionally wasting a bunch of the server's resources. And the way that they do this is they will do something like sending like HTTP headers in a way where they have been specifically crafted based on their knowledge that your web server, let's say, is running Python, and they know that your web server that you're running, let's say it's one of the popular ones, one of the first things that it does on every single request is it takes all those headers and it puts them in a hash map. And so what they do is they specifically craft the headers such that every single, or as much as possible, all the headers will cause hash collisions in the hash map and therefore degrade the performance of all of, when it goes through and looks for is this header in there? It'll be like, oh no, now that's going to collide a ton. And, just looking for the authentication header or whatever is just going to be super slow. And now the server's wasting even more time on every single one of these malicious requests. So there's a very famous, I shouldn't say very famous, but I guess there's a widely watched talk from DJB talking about how they researchers sort of demonstrated the proof of concept of this, and then also their recommended mitigation. Their recommended mitigation is essentially have a hashing function that incorporates some randomness so that you can't guess it. You can't craft this specific payload. Well, a lot of languages adopted this. So Python, Perl, Go, they all do this by default. Rust by default uses SIP-hash, which is their hasher that does this. However, as a functional language, I have a big problem with doing that, because that means that now you open up your REPL and you're like, hey, let me make a dictionary, which we use as a hash map under the hood. And now it's like, oh yeah, bad news. That's actually now completely going to be different, like every single time you run the REPL by design. It's like, cool. That's not what I want in a functional language at all. I want it to be completely consistent, actually. I want everything to be reproducible. But of course, that reproducibility leads to the vulnerability. So it turns out, though, in the actual paper, and even the talk, he mentions this very briefly. He's like, that's one way you can do it, but another way you can mitigate it is in the hash map itself, and how the hash map itself does collision resolution. And you can make that sort of non-deterministic without altering the order of things when you like traverse it, for example, which changing the hash function does. So that's what we ended up doing. Shout out to Brendan Hansknecht. He came up with this really cool idea for how to do that in a sort of platform agnostic way, which is basically that operating systems already do this thing called address randomization to try to prevent certain categories of attacks. And so what we do is when you load up the ROC program, since ROC doesn't innately know about like system sources of randomness, what we do is we have some like random address that we just put in memory. We look at that address and we make a seed based on that when the thing starts up. So you can use that as a way to, like, without having to go ask the OS for randomness, as some sort of like a basic seed for making it so that collision resolution is somewhat random. And I think he also made it based on rehashing rather than on anything else, so that you don't need any additional constraints beyond, like, this thing is hashable. But it was really cool. Like, he did some simulated, like, okay, what if I tried to do a hash flooding attack, on this dictionary, and like it was really effective at like reducing the efficacy of that attack. So it's just really interesting how, like, bringing it all the way back to like upgrades and like vulnerabilities, and like where should things be mitigated and whatnot, is it's like, yeah, it can be surprisingly difficult and like a lot of work to try to mitigate something without sacrificing performance the way that like Spectre and Meltdown things did, while also trying to maintain the other characteristics you have. Like in our case, it's a functional language, and we want things to be reproducible as far as what you are able to observe in user space, while behind the scenes actually the performance might vary randomly. That seems like the right trade-off for us, but for another project it might be a totally different set of trade-offs.
Yeah, to connect that to like the initial thing about like making a framework, using a framework versus just like going without it. Programming languages and runtimes are kind of that framework. And if you were gonna make your own, like if you had to implement all your data structures, all your algorithms that you needed ever, you need so much prior context and like knowledge of like how do I implement these algorithms so that they're not vulnerable to hash flooding or whatever. Um, and you can kind of assume, or hopefully assume, that a lot of frameworks have taken care of stuff like cross-site scripting. Like if we talk about
Yep.
React, then like cross-site scripting or like these kind of problems. They obviously can't handle all the edge cases or all the vulnerabilities, but someone else has thought about it for you already.
Yeah.
Yeah,
And there's a lot of value in that. I mean, and I think that also gets back to the trade-off we were talking about of sort of like engines versus like, you know, customizing it yourself. It's like when you're in a security critical context, it's not just about convenience versus bloat versus customization. It's also about like, do I even know how to make this thing secure? The most famous example of this being the old adage, don't roll your own cryptography. Like,
yeah,
leave that to the experts. Otherwise, you're gonna make an implementation that's vulnerable and not realize it. And I mean, certainly that's true of me. I don't I don't know nearly enough about
yeah.
cryptography to try and feel any kind of confidence in implementing my own crypto algorithms, which is why we're using off-the-shelf ones for the standard library. Although having said that, there are some cases where I think there's maybe the opposite dynamic is at play, where it's like it feels like something is out of reach, but actually it is possible to do it yourself. So this also came up recently, also in the context of something Brendan's been working on. So because of some changes to the compiler, we recently got the ability to do a new style of concurrency that wasn't previously viable, which is essentially where the code ends up looking like and kind of working like Go code, where you can essentially do something that looks like you're doing just normal synchronous, like run this, do this HTTP request, and then on the next line, after I've done that, do this other HTTP request. After next line, do this, file IO. And in Go, if you do something like that, those can all look like they're just normal sequential. You don't have to do any async await, stuff with those. But behind the scenes, they're actually implemented as non-blocking. And when the program gets to those points, it'll be like, oh, I'm gonna like automatically switch to letting this CPU that's running right now do some more work while we wait for that HTTP response to come back. Because what else are we gonna do? We're just, we have nothing else that we could possibly do until it comes back. And there's plenty of other, requests we could be servicing right now. So basically, we found a way to make that work using Rock's platforms and applications thing, and it's a stack full of coroutines. It has the same general characteristics as Go in terms of both ergonomics as well as in terms of performance, and it just kind of required being like, "Hey, I bet we could do this. Let's try it." And obviously, like making a fully featured system out of that is a lot of work. Like Brendan got the basic proof of concept working, and it benchmarks quite well and is like really cool and like feels ergonomic. But then you get into stuff like, it's like, yeah, but now you have to build a whole HTTP server around that. It's like now we have this really cool foundation, but none of the like we can't like reuse this whole ecosystem that doesn't exist around these primitives. And so now you have to get into like really basic stuff like, okay, we got to like parse some headers and, like generate response headers and things like that. All of which are doable, but, and also like, some bugs to fix, but it's interesting just how like the part of the project that you might assume would be the thing that's like really far out of reach actually turns out to be quite doable. And now we're at the point where like we're like, oh well, maybe we can like find some volunteers who are interested in like working on the the less ridiculous parts of it to be able to maximize those benefits. But I think that's something that a lot of projects don't even like attempt.
Yeah, and it's kind of interesting when you think about like when people talk about innovation, for example, then you always say that restriction leads to innovation in some
Totally.
ways, because you're, instead of having total freedom, you're restricted to a particular like box, and once you're in that box, then you have to figure out like the things you can do inside of it, which might end up being totally new ideas, totally new concepts, or totally new approaches, building on things that already exist usually.
Yeah.
But still, like, okay, we have these security limitations, like we have these performance limitations. What can we do within this area to make it secure and performing at the same time?
Right. Yeah, a lot of that actually came up in the thing I was just talking about, where if you're doing like Stackful coroutines like that, where you're making your own stack off to the side, like basically it's like AKA green threads, is Stackful coroutines, and the basic idea is that normally each operating system thread has its own stack, which is some fixed size, like some number of kilobytes, and the way that the OS knows if you ran out of stack space to give you a Stack Overflow error is just that it allocates some certain number of pages of memory for each of those stacks, and you start off at the beginning, and then every time your program's like, oh, I want some more stack space, just like bumps an address pointer up, and eventually you can potentially go off the end of that because it's not checking every single time to see like, oh, did we go over? It's like, no, it's just for performance, it's just bumping it up and up. And what it does is it automatically inserts an extra page after that, which is read only. So as you're bumping up and up, because these are stack pointers, you're only going to be bumping up by pretty small increments at a time. And you, if you get into that extra page, like you've exceeded the allocated amount of stack space, and you try to write into it, and it's read only, then you automatically get an operating system fault, and then that's where you're like, okay, now we're in Stack Overflow territory. But there's this thing called a stack smashing attack, which is essentially where you say, well, I know how big a page is. If I know that there's just this one guard page, because of course you don't want to like make the entire rest of memory read only, because then you don't have room for your heap or anything else. So the idea is that you say, okay, I'm going to try to use like an array or something that's like really, really big and uninitialized or something like that, and try to access a really, really late like offset into that array. The idea being, if the whole array is on the stack and I access some really, really, index number 1,000,000, that'll jump all the way off the past the stack page, so you won't get a Stack Overflow when you try to put this on the stack, as long as you don't like allocate anything else after that. So you have to, I guess it's like a pretty tricky attack to execute, but the idea is that then you can dereference that, and then now you're reading memory that's in the heap, and now you can like use that to exfiltrate secrets and stuff like that, as long as you're very, very careful about it. Of course, the problem with something like that is that it really, if I'm the attacker, is that it relies on the language and the runtime of the language allowing me to do something like that. And so our solution to that at a language level is basically to be like, yeah, we don't really mess around with like uninitialized memory. If you try to allocate a giant array like that on the stack, we're going to put a bunch of zeros in there, and guess what? That's going to write into the guard page among other pages, and it's going to blow up. The other tricky part about that is that you do need to make sure that you write in the correct order. So if you sort of naively write to like any order, then you could end up overwriting some heap pages before you get to the guard page, and that could cause its own problems where now you're modifying heap memory instead of reading it. So all those things are sort of like, yeah, if you're just delegating to like a JavaScript runtime like V8 or something like that, you're not really worried about any of that. But if you're going sort of bare metal like we are and just compiling it straight to machine code, this does become something you have to worry about.
Yeah, and that's the whole bespoke versus like using something that's already off the shelf that's provided for you kind of problem. I think it's an interesting thing because I think it requires like the combination of being passionate about the problem, having the sort of either the expertise or the ability to find out, like to get the expertise, to either you already have the knowledge or to get the knowledge on how to implement that stuff properly. And then also like the motivation, like what are you getting out of it if you don't go bespoke and like entirely custom. And I guess in your case, like it's performance and not depending on like other runtimes to run your code and like all that kind of stuff. But I think it's something that you have to think about. Like I could rewrite, for example, I could rewrite the charity website very quickly because it wasn't that complicated technically, and I know HTML and CSS,
right?
So it didn't take that much effort. But then on the other hand, like a non-technical person, that would take a ton of effort, and they don't have the they might have the passion for it, so they tick $1, but they don't have the knowledge or the desire to gain the knowledge on how to do it. But then that's where like AI kind of comes in, where I kind of think that these ChatGPT or Copilot or whatever, they enable a bunch of people to do technical things that before they just considered like, okay, some programmers they know how to do this magic. I don't know how to do it, so I just won't do it. But now you can get a lot done with ChatGPT if you don't know anything about programming. Like,
Yeah, and actually, I mean, I've found that even as like a very experienced programmer, that I can get value out of using it for exploration. And actually, that specifically came up in the Stackful coroutines thing, where like because I had honestly just like watched a lot of Casey Muratori's like courses on like really low level programming, I had this idea in my head of, it seems like it should be possible, given what I know about Rock and what I know about low level OS stuff, that we should be able to do this in the platforms and applications sort of system. But I wasn't sure. I was able to generate a proof of concept in C just by sort of having a conversation back and forth with it, just to prove out like, oh yeah, actually, given our constraints, like this actually is viable on a basic level. And then I was able to show that to Brendan and be like, hey, look, like this actually seems like a plausible thing to try. I don't know if it would have made sense for him to even like go down that road of building what he built without the knowledge that like at a basic level it could actually work. And so I think that's I like the way you put that. It's like it's a way to use existing technology to sort of remove barriers of like being able to try things that previously might have been out of reach because either you don't have the technical skill at all, or you have it, but it would just take so long to even answer the question of like, is this a reasonable direction to go down, that you wouldn't make that investment in the first place.
yeah, there's like all these tools like what's it called? If this then that.
Oh yeah.
I don't know if you've seen the IFTTT. Is that what it's called?
Yep.
Um, where you can like program your home automation stuff. Like you can make it do things in a without writing any code. Like it's drag and drop, and you just choose things that happen. Um, but I kind of feel like talking to ChatGPT or any or cloud or like Llama or whatever is such a better way for most average people to be able to like ask, okay, I'm trying to do this particular thing. How do like can you make it happen?
Yeah.
And then maybe on the back end it goes through if this then that, or it goes through shortcuts on iOS or like modes and routines on Samsung or whatever.
Sure.
Or maybe it writes a Python script. You know, like if you're trying to convert some data source into a CSV so you can put it in Excel, then previously that knowledge has kind of been like gate kept
Right.
unintentionally by programmers because we know how to program. Like some of this stuff is very easy to do for us, but the average person doesn't particularly know what Python is or how to write a script in it
Right.
or what file formats are. You know, like they don't know about this stuff. And ChatGPT, or I should use generative AI in general, lowers that boundary. And I was talking to someone recently where they had a data source and they needed to convert it to Excel format, and they spent a long time with ChatGPT generating something that would do exactly that, and then it ran it, and then it like magically worked.
Yeah.
I did say to them like, "How long did it take you to get to that point?" And they were like 20 minutes, and I was like, "I could have wrote a script in like 4 minutes that would have done the same work and like used less computation time and like been better for the environment and like all these things." But I did like combine that with like, it's amazing that this stuff is accessible to you now, because before you either would not have been able to do that and therefore entered it manually or like given up or waited for a programmer to have time to do that. And now we can like humans can talk to something and have it understand what they need and what they're trying to do, and use like the collective knowledge of the training model to build tools, build products, etc. I'm not like super hype on AI, I will say. I know it might sound like that. I think there's a lot of bad things and downsides to it too. But I think for making tech accessible, it's really really impressive.
Yeah, my dad's actually a great example of that. So he's not a programmer at all, but he's a scientist. He does like microbiology research, so a lot of stuff with DNA sequences. And so pretty much my whole life since I learned how to program, periodically he would hit me up and be like, "Hey, can you write me a program that does blah?" And blah is always some form of like pattern matching on like or looking for patterns in like long DNA sequences. Um, he doesn't need to do that anymore or he doesn't need to ask me to do it anymore because now he can just go to ChatGPT or something and be like, "Hey, write me a Python program that does this." And at best, he can send it to me and be like, "Hey, does this code look right?" Or is it just working on my examples, but might fall down on a larger one? And so far, that hasn't come up. Like all the time that he's sent me one, and I look at it, it's like, yeah, that looks like it's doing what you want it to do, which is a much faster feedback loop for him because he used to have to wait, until like I had some free time to like sit down and a lot of it was just me trying to be careful and understand his requirements. Like, what is he actually looking for? Whereas just being able to get instantaneous, like, here's your program, here's how to run it. And then, if he wants a variation on that, ask that. And he gets it out right away. For those types of really small, simple programs, it's amazing for him. And, if he needed some gigantic, elaborate application built, it would not go as well for him. But he doesn't need that, right? Like his work as a scientist doesn't require something that big. What he really needs is to be able to quickly get small scripts that do things that are customized to what he needs. And yeah, it's amazingly accessible for him now in a way that
Yeah.
it never was before.
The largest program that I know that someone is like actively using, entirely generated by ChatGPT, or I think Cloud, actually Cloud 3.5, is 4,000 lines of code. The person who has it did not write any code, doesn't know how to code, but like has incrementally like asked like, okay, what do I need to do this, what do I need to do this, and then just combine it all together. And I think that's amazing. At the same time, it sets off alarm bells from like security and like performance and like,
Yeah.
Okay, what is this 4,000 lines of code actually doing? And
Right.
there was not a human involved in like verifying it or like verifying the code itself. So it might be that there's a random like HTTP request somewhere in there that just sends your credentials off to like a random server or something.
Right. No, I mean, I was reviewing some code recently. From this was not at work. It was some other context. But I was looking at it and I was like, okay, this very much looks like it was written by an LLM, like this chunk of code, and not cleaned up by a human. Because there's certain things where it's like there's just extra methods on there that are not obviously not used. Like they're just like public and exposed, and like they were just kind of implemented apparently because the author asked it to generate, like they needed like 2 of these methods and it went ahead and generated 8 of them. The other 6 are like variations on the first 2 that they actually used. And they're all like documented in exactly the same style, even though the others are unused. And there's a lot of sort of really non-helpful comments like in a lot of places that are just like, oh, this is the ID for blah. And it's like foo : ID blah. It's like, okay, yes, yeah, thank you. Like I know what that is. I can read the next line. And when I see that, on the one hand, I'm like, cool, you're getting value out of a large language model. But like, just like you said, it sets off alarm bells where I'm like, so if you didn't clean this up, did you vet it? Do you know how to vet it? Like, definitely there is a category of mistakes that large language models just unequivocally make. If I can see that the code has not been cleaned up by a human, I have very low confidence that like if one of those types of mistakes snuck in here, that it was caught, because it seems like a human didn't even bother to look over what was generated. So that concerns me. Yeah, like on the one hand, it's cool that like they were able to save time, but on the other hand, if you don't go through and review after the fact, you're saving time while also cutting corners, and in some cases, those corners being cut can be a lot more serious than others.
Yeah, like if it's a low stakes solution that it runs inside a VM, like a virtual machine that has no network access, you don't give it any kind of private data, credentials, anything like that, then you can run whatever you want. Like, yeah, that's
Sure.
fine. Just do it.
Right.
But as soon as you like are in the real world where you actually have to give it useful data so they can do things, you have to let it have network access so that it can do things again, and give it credentials so it can like log into whatever API that you might have. That's when it starts to become really concerning.
Yep.
And I think we're gonna see more and more of this kind of stuff happen. And I don't think it's a bad thing, but it's something that has to be cautious. And like as software engineers, part of our like what's the word? Not like principle, but our sector. Yeah, our sector is we use our knowledge to write code, but we also use our knowledge to review code and understand not only what the code does, but what it does in relation to the requirements, what it's meant to do, what is strange for it to do, what it's performant for it to do. And I think a lot of organizations that might end up with these people who are not developers generating code running it, they should probably have some rules and guidelines about like, how do you deal with that? Do you commit it into your regular code base as if it's a regular PR? Do you review it like that? Do you run it inside these like Docker containers with no network access? Do you sit with the person who's generated it and like listen to them as they explain it to you and what it's meant to do and why it got so big and like all these different things? And I don't think many places have those kind of rules or things in place yet. Like either the rule is just like there is no rule, so do whatever you want.
Right.
Or the rule is like super restrictive, like don't use any of these AI generated code. But I think the reality that is going to set in is that you're going to need to allow it, but you're also going to need to use the human expertise and knowledge that we have to make sure that it's doing the right thing.
Absolutely. Yeah. And it'll be interesting to see how long it takes us to figure out how to strike that balance.
Yeah, we're not there yet. And you know, AI is moving at a pretty good pace. So where we're at today is going to be totally different in like even a year, probably.
Could be.
The charity that I was helping out, we ended up looking at cards.co as a solution for that.
This is for credit card processing or something like that.
No, I can't remember if it's card or if it's cards. It's card. It's basically like a one pager type thing. So WYSIWYG, thing designed for landing pages, so you can just put a bunch of stuff in there.
Interesting.
And it would be very handy to have someone who's an expert in that. So if there is anyone who's watching or listening to this who wants to help a charity that helps empower youth to become future social changers within society, then please reach out to me.
Nice. And yeah, I'll include some contact info in the description.
Yep. Yeah, I think that's pretty much it that's on my mind right now.
Awesome. Nice. Well, we talked about a lot of cool stuff. I really appreciate your taking the time and a lot of thought-provoking stuff.
Yeah, definitely. It's I always love having these like open-ended discussions that go random places, and I didn't expect to talk that much about security.
Me neither, but it did help me sort of like solidify a lot of thoughts that I've been sort of like bumbling around in my head. So appreciate the conversation. Always great to catch up.
Yeah, likewise.
All right.
Cool. See you later.
That's it for this one. I hope you liked it. You can find links to some of the things that Noah and I talked about in the description. And if you'd like to become a supporter of Software Unscripted, check out patreon.com/softwareunscripted. I'd really appreciate it. Until next time.